Evening, everyone. Am I audible, guys?
Yes, sir.
We'll get started.
Yes, sir.
Oh, 1 minute. I'll be back. 1 minute. Okay. So today's topic is alternating current, right? Yes. So shall we get started with this alternating current? So like every day, today also we are going to discuss problems. So yes. Now let us discuss the examples that are based on mean effective instantaneous values of alternating currents and voltages. Okay, alternating currents and voltages. What is the formula used? So if you have instantaneous value of AC, it is given as I is equal to I naught into sine omega t, where I naught is called as the peak or the maximum value of alternating current. Right. So do you guys know this expression? So where did we get it from? E is equal to E naught sine omega t. And what is the value of E naught? NBA omega into sine of omega t. Accepted. Next. Average or mean value of AC over half cycle. So that is the next one. So what is going to be the average value of alternating current? It is going to be 0.637 times I naught. And what is going to be the effective or RMS or virtual value of AC given as? It is given as I naught divided by root 2 or 0.707 times I naught. Right. And for alternating voltages, the same thing is applicable except the fact that I is replaced with E and I naught is replaced with E naught. That's it. Right. So having said this, can we get started with the problems? Is there anyone having doubt with any of the concepts here? Okay. So tell me how to solve this problem. The electric mains in the house are marked 220 volt and 50 hertz. Write down the equation for the instantaneous voltage. Now tell me one thing. What is this 220 volt equal to? What voltage is that?
ERMS.
It is ERMS. So ERMS is equal to how much? 220 volt. Frequency is 50 hertz. And write down the equation for the instantaneous voltage. So E will be equal to E naught into sine omega t. If F is 50, what is the value of omega? 100 pi. Correct? If ERMS is equal to 220 implies what is the value of E naught? Answer.
Sir, this thing,
0.7072.
ERMS divided by 0.737.
ERMS divided by root 2 is equal to E naught. Sorry. ERMS is E naught divided by root 2. Okay. So E naught will be root 2 into ERMS, because remember, E naught is a peak value that has to be the maximum. So it cannot get divided by root 2, it has to get multiplied with root 2. So 220 into root 2 will approximately give you 314, I guess. Okay. 314 into sine of, in the place of omega, I can write it as 100 pi into t. You can expect this as an MCQ question. Right? You can expect this in MCQs where they ask you the instantaneous value. Clear? Shall I proceed to the next one? An electric bulb operates at 12 volt DC. If the bulb is connected to an AC source and gives the normal brightness, what would be the peak value of the source? So, for us to find the peak value, we either need E RMS or E average. Am I right? Because these are the two parameters which are related to E naught. Now the question is, here they didn't speak anything about ERMS or E average. They directly gave us 12 volt DC. So this 12 volt corresponds to which value? Corresponds to which value? Answer is, this is what is ERMS. I want everybody to remember this. ERMS and E average both are DCs. Okay. So ERMS comes into picture when the heating effect is the same. E average comes into picture when the current passed is same. So when they say current is same in both the scenario, that time you will use E average. So this ERMS is actually 12 volt. If ERMS is 12 volt, can you find E naught? It is 12 root 2. So 12 into 1.414, whatever is the answer, that you can write it. So it will approximately be 17.
Sir.
Tell me.
Sir, in the previous sum, E naught is 311, right?
311, huh? Okay. I wrote an
Yes, sir.
approximate 311 sine omega, sine 100 by into t. Okay. But is this concept clear to everyone? It is 17V.
Yes, sir.
Yes, sir.
So the peak value of an alternating voltage applied to a 50 ohm resistance is 10 volt. So E naught is equal to 10 volt. E RMS will be equal to find the RMS current. So E RMS will be 10
Sir.
by root 2.
E naught upon root.
I RMS will be ERMS divided by capital R. So 10 divided by 50 root 2 or 1 by 5 root 2. It will be root 2 by 5.
Sir, could you go to the previous problem for a second?
What happened?
Sir, they're asking your brightness, right?
If the bulb is connected to an AC source and glows with the same brightness, that is the meaning. And the bulb is giving the brightness. If that is giving the brightness, then what would be the peak value of the AC source across which you connected that bulb? Is what the question is.
Understood, sir. Yes.
So root 2 divided by 5. Root 2 is 1.414 divided by, actually it is not 5, 5 into 2, 10. It will be 0.1414, right? Or you can write it as 141.4 milliampere. So write the value of instantaneous current. So I will be equal to I naught into sine omega t. I naught eவ்வளோ? How much is I naught? E naught is 10. I naught will be
0.2. 0.2.
0.2.
1/5. Yes, sir.
So 0.2 into sine of, what is the value of omega?
100. 100.
So F is 100, omega eவ்வளோ? Omega is 2 pi f.
Okay, sir. 200 pi.
200 pi.
It should be 200 pi into t. So 0.2 into 200 sine, sorry, sine 200 pi into t. These many amperes. Okay. So the electric current in a circuit is given by I is equal to I naught into t divided by tau for some time. Calculate the RMS value for a period of t is equal to 0 to t is equal to tau. So how to find the RMS value? What is RMS in the first place? Root
Mean square.
mean square. So here when they say root, it is actually the square root. So square root of I square dt's integral divided by integral of dt is what is going to be the RMS value. Am I right? So first let me calculate the value inside the square root. So integral of I square dt divided by integral of dt between 0 to tau, and here also between 0 to tau. So I square is how much? I naught into t divided by tau, the whole square dt between 0 to tau divided by integral of dt between 0 to tau is going to be tau. Right? So I naught square by tau square can come out of the integral, and you have a tau in the denominator, integral of t square dt between 0 to tau. So this will be how much? I naught square divided by tau cube into what is the integral of t square dt? It is going to be t cube by 3, or it is going to be tau cube by 3. This and this will get cancelled. You will have I naught square divided by 3 is the average of the square. It is only mean square, but we need RMS. So I RMS will be equal to square root of I naught square by 3. What will be the answer? I naught divided by root 3. Okay. Next. So let us see some problems that are based on series LR circuit. So you know what does a series LR circuit do? But before that, I have a question, okay? When you connect an AC source across a resistor, then what is the relation between current and EMF? Guys, I asked you a simple question. What is the relation between them? EMF and current, they both are going to be in the same phase. Similarly, if E is equal to E naught sine omega t, I will be equal to I naught sine omega t. Then what about you connecting a capacitor across an AC source? If E is equal to E naught sine omega t, what will be the value of I?
I naught sin omega t plus pi by 2.
I naught.
Sin omega t plus pi by 2.
So what happens here? Current,
Current leads C naught by pi by 2. Please.
current leads voltage by pi by 2. What about an inductor then?
Current lags voltage by pi by 2.
So you'll get I naught sine of omega t minus pi by 2. So current lags the voltage by pi by 2. So what is the value of I naught here in the case of capacitor? It will be E naught divided by XC.
Omega.
So XC is equal to 1 by omega C, the capacitor.
Yes, sir.
Similarly, I naught will be E naught divided by XL. So what is XL? E naught divided by omega into L. I hope everybody knows these values. Right. So what is this XC called as? XC is called as,
Capacitive reactance.
XL is called as inductive
Inductive
reactance. So when you take the combination of any two devices with the resistor, like resistor and inductor, resistor and capacitor, or resistor, inductor and capacitor, then what are all the parameters that are going to come? So I have one. If it is a resistor, then the opposing parameter you speak about is called as resistance. If it is a capacitor or inductor, then the resistive parameter you are going to speak about is capacitor reactance or inductive reactance. If it is a resistor, capacitor, or resistor, inductor, or resistor, inductor, and capacitor, then what do you speak about? The resisting parameter is called as impedance, and impedance is represented by the symbol Z. Reactance is represented by the symbol X, and resistance is represented by the symbol R. I hope it is clear. So what is going to be the formula for impedance? Impedance will be equal to ERMS divided by IRMS, which is going to give us the value of root of R square plus XL square or R square plus omega square L square if it is a series LR circuit. Okay, what is the value of IRMS then? IRMS will be equal to ERMS divided by Z. So sometimes in the problem, you will be asked to calculate the phase angle. Then the phase angle is given by XL divided by R or omega L divided by R. Then what about cos phi? Cos phi will be equal to R divided by Z, where R is going to be the resistance and Z is going to be the impedance, right? So having all these points in mind, let's look at the first problem. When an inductor L and resistor R in series are connected across 12 volt and 50 hertz supply, a current of 0.5 ampere flows in the circuit. The current differs in phase from applied voltage by pi by 3. Calculate the value of R. So what is the value of Z? ERMS divided by IRMS. ERMS is 12, IRMS is 0.5. So how much is going to be the answer? 24. Right, 24 ohm is going to be the impedance. The current differs in phase from applied voltage by pi by 3 radian. So phi is equal to pi by 3. Calculate the value of R. So how to calculate? Tan phi is equal to, sorry, cos phi is equal to R divided by Z, which implies cos of pi by 3 is equal to what is the value of R?
You
That's
have to
what we know.
find.
R divided by Z is going to be 24. So which implies half is equal to R divided by 24. It is going to get cancelled 12. So R will be equal to 12 ohm. I hope it is clear.
Yes, sir.
Copy it. Make it fast. Solve this. So listen to this. Resistance is given as 10 ohm. Inductance, I took it as L. So V is 100 volt and the frequency is going to be 50 hertz. Phi is equal to pi by 4. So what is tan phi equal to? Tan phi is equal to XL divided by R, which is also omega into L divided by R. But tan phi is going to be pi by 4. So tan pi by 4 is equal to, in the place of omega, we can write it as 2 pi into F into L divided by R. So 2 pi into F is going to be 50 into L divided by R. So taking the values on both the sides, 1 will be equal to this value. And on solving this, you will get L is equal to 1 by 10th of a pi. Sorry, 1 by 10 pi. Next, a coil of resistance 300 ohm and inductance 1 Henry. So coil of resistance 300 ohm and inductance 1 Henry is connected across an alternating voltage of 300 divided by 2 pi hertz. So frequency is equal to 300 divided by 2 pi hertz. Then what is going to be the value of omega? Omega will be 300 radian per second. Calculate the phase difference between the voltage and the current in the circuit. So tan phi again will be equal to omega into L divided by R. Omega is 2 pi into F into L divided by R. So 2 pi into F is, okay, 2 pi into F is not needed actually, because we have already calculated omega.
So 45.
Okay. So 300 divided by R is going to be 300, cancel. So phi will be in terms of radian pi by 4. Or
So is the answer 300?
which one is 300? No, no, they asked the phase difference. No,
Oh, sorry, sir.
But-
I didn't see.
yeah. So omega into L is also 1. This is 1. Okay. So phi will be pi by 4 or 45 degrees. Okay. An 80 volt, 800 watt heater is operated at 100 volt and 50 hertz supply. Calculate the inductance of the choke required. Choke is basically R and L connected in series. Actually, this you can ignore light. This is also not needed. Try this. A student connects a long air core coil of manganese wire to a 100 volt DC source and records a current of 1.5 ampere. When the same coil is connected across a 100 volt 50 hertz AC source, the current decreases to 1. Give reason for this observation. Calculate the value of the reactance of the coil. So what is the answer for the first one?
Sir, since it's a DC source, there is no change in current. So so at first it will have some reactance to it, but then it will now then have a steady current because omega becomes 0. But in an AC source, omega does not become 0. So it will have a bit of reactance, which will cause self-inductance and a current opposing the flow of current will be caused.
Okay. Second one, calculate the value of the reactance. So what is going to be the reactance? So Z will be root of R square plus XL square. So root of, what is the value of R square? So R you can calculate from this. So what is the value of R? 100 divided by 1.5, maybe 200 by 3. L will be Actually, they ask calculate the value of the reactance of the coil. That's my mistake. So first of all, what is going to be the impedance, guys? So what is going to be the value of impedance? Impedance is going to be 100 divided by
1.5.
1. No, 1. And impedance is coming only in the case of AC. So 100 divided
Yes,
by
sir.
1 is going to be 100 ohm. Resistance is how much? Resistance is how much? Now you will use this 100 divided by 1.5, which is going to be 200 by 3. So Z square is equal to R square plus XL square. They ask the reactance directly, which implies XL square is equal to Z square minus R square. So XL square is equal to Z square is how much? 100 square minus R square is 200 by 3 the whole square. So it is 10 power 4 minus 4 into 10 power 4 by 3. Sorry, by 9. So it will give 5 into 10 power 4 by 9. Then what is the value of XL? 1 by 3 or 10 square by 3 into root 5.
So 100
This is
root
going to
5.
be the value. Why 100 root 5?
So same only, so 10 square 100. 10 root 5 there.
Yes, sir. You told 100 into root 5 or you told that 100 is there inside? I didn't understand because your voice broke.
Oh,
This correct only.
100 root 5 by 3.
So root 5 is 2.25. 2.25 by 3. It should approximately be somewhere around 8, but less than that. 7 point something will come. Okay. Next. So similar is the case for the series RC circuit, except the fact that instead of XL, you will have XC, and in the place of XC, you can write it as 1 by omega C. So XC square is 1 by omega square
Sir,
C square. Tell me.
sir, it's 71 now. How 7.1?
Okay, that's what. See, I took it like this. 2.2 divided, I took it as 2.4 divided by 3.8 into 100. Okay, it will be somewhere around 70 is what I told. Because 2.25 will come. I did a rough calculation of 2.4 and told answer should be less than that. So it is 70 point something, 70 odd, that number will be there. So answer is 74.35. As I told you, calculation part, I'm leaving it to you. Okay. So impedance is going to be root of R square plus X square, or it is going to be R square plus 1 by omega square C square. So what is going to be the value of IRMS? IRMS will be ERMS divided by Z. So what is going to be the value of tan phi? Instead of XL divided by R, you will have XC divided by R, or it is going to be 1 by omega C divided by R. So what is the value of cos phi? Cos phi will be R divided by Z. Okay. So try this. I'll be back. Keep trying. What is the answer? So I is equal to how much? So you'll calculate V effective and divide it with Z. Z is what value did you get for Z? Z is equal to root of R square plus 1 by omega is equal to 100 pi. Okay. So 10 power 4 pi square into C square. So 50 into 10 power minus 6. This is calculation going bit tough.
Sir, 15 to 10 power minus 6 whole square.
Whole square. So how much is the value of Z you are getting? At least approximate value. So it is 64.4 ohm. Right. V effective is how much? V effective is 200. So 200 divided by 64.4 ohm will give you the answer as 3.10 ampere. Okay. Do this.
Sir,
an
can we go to the previous question?
Make a note of this value. Try calculation part, you do it later. Done.
Yes, sir.
Do this now. When an alternating voltage of 220 volt is applied across a device X, a current of 0.5 ampere flows through the circuit and is in phase with the applied voltage. So what is the device X? The resistor. When the same voltage is applied across another device Y, the same current flows through the circuit, but it leads the applied voltage by pi by 2. Y is a
Capacitor.
capacitor. Name the devices X and Y. Okay, done. Calculate the current flowing in the circuit when the voltage applied across the series combination of X and Y. So I is equal to V effective divided by Z. So V effective is 220 divided by Z is going to be root of R square plus XC square. So what you do is first calculate XC separately and then bring it here. Don't do it within the square root. So what will be the answer for XC guys here? One thing is they didn't give you the capacitance value, they didn't give you the frequency also. So how will you calculate? One hint that is given in the question is when you pass 220 volt, the same 0.5 ampere flows in both the scenarios. So what is the relation between R and XC? R and XC both are same, and how much is the value going to be? 220 divided by 220 divided by sorry 440 root 2. Because R and XC are the same. So square root of 4.
Sir, your voice is breaking. Was
Is it better now? Guys, is it better now?
yes, sir.
Okay. So root of 400, you understood why it is 440? Because 220 volt is producing 0.5 ampere in both the scenarios. So root of 440 square will be 440 into root 2. So 440 gets cancelled twice. So 1 by 2 into root 2. So root 2 divided by 8 will be the answer. That is 1.414 divided by
So
8.
root 2 by 4, no, sir.
Root 2 by 4, sorry. So 1.414 divided by 4 should be the answer. How much will it be? 0.321 means 5 and 3. It keeps on going. So this is going to be the value of current, 0.353 ampere.
Sir, how did we get the root 2?
Because root of a square plus a square is root 2a square.
Oh,
Which is-
okay, okay. Sir. Yes, sir, got it.
So 0.353 ampere, or yeah, approximated to 0.35 ampere. Can make a note of it. Okay. Next. Do this. A series circuit contains a resistor of 20 ohm and a capacitor and an ammeter of negligible resistance. It is connected to a source of 220 volt and 50 hertz. If the reading of the ammeter is 2.5 ampere, calculate the reactance of the capacitor. So resistor is 20 ohm, capacitor and a capacitor. Okay. XC is equal to how much is what we need to find. Voltage is 220, frequency is 50 hertz. The reading of the ammeter is 2.5. So I is equal to V effective divided by Z. So which implies 2.5 is 5 by 2 is equal to V effective is 220 divided by Z. So Z will be equal to 440 by 5, which is going to be 88. So Z is 88 ohm. Z square will be equal to R square plus XC square, which implies 88 square is equal to R square is how much? 20 square plus XC square. So XC square will be equal to 88 square minus 20 square, or 88 minus 20 into 88 plus 20. So 88 minus 20 is 68 and 88 plus 20 is going to be 0. Sorry, 108. So 68 into 108 under a root is going to be the answer. Guys, did my voice break now? I think I have some unstable connection today. Am I audible now? Can someone respond?
Yes, sir.
Okay.
Yes, sir.
Was this problem completely understandable? Because I don't know when my voice broke.
Sir, it's approximately 85.69.
Approximately
85.69.
correct. So I was telling this concept. Did you understand what I did there?
Yes, sir.
I did prime factorization so that I can reduce these values and multiplication values. Arvind, are you clear?
Yes, sir.
No. Do this one. An alternating current of 1.5 milliampere RMS and an angular frequency of 100 radians per second flows through a 10 kilo ohm resistor and 0.5 microfarad capacitor in series. Calculate the value of RMS voltage across the capacitor and impedance of the circuit. So I is equal to 1.5 into 10 power minus 3 ampere. Omega is equal to 100 radians per second. Resistance is 10 kilo ohm, so 10 into 10 power 3 ohm. And capacitance is 0.5 into 10 power minus 6 farad. So they both are connected in series. Calculate the value of RMS voltage across the capacitor and the impedance of the circuit. So two values are to be calculated. Correct? So I effective is 1.5 into 10 power minus 3 divided by XC is going to be how much? XC will be one. Sorry?
Z won't come, sir. Like I effective by Z.
Read the question. Calculate the value of RMS voltage across the capacitor. So if a resistor and capacitor, when they are connected in series, the current through both the devices is same.
Yes, sir.
See, that's what happens. No, so current is 1.3 into 10 power minus 5. Since they asked across the capacitor, I need to use 1 by omega C. Purida. So
Yes,
1
sir.
point into 10 power minus 3 divided by omega is going to be 100. C order. 1 by 2 into 10 power minus 6. So this 2 will go to the numerator. So 3 into 10 power minus 3 divided by 10 power minus 4. That will be 3 into 10 power minus 3 into 10 power 4. That will be 30 volt. Am I clear with this? Right. So 30 volt is going to be the voltage across, effective voltage across the capacitor. Now, what is going to be the impedance of the circuit? So impedance will be root of R square plus XC square. So what is the value of XC, guys? Is it not 0.5 into 10 power minus 4? So XC is equal to 0.5 into 10 power minus 4. So XC square will be how much? Or I can write as 5 into 10 power minus 5. So XC square will be 25 into 10 power minus 10. R is how much? R is 10 into 10 power 3. So R square will be this value. Z will be equal to square root of R square is 10 power 4, the whole square is 10 power 8 plus 25 into 10 power minus 10. So 10 power 8 plus 25 into 10 power minus 10 is a very, very small value. If I approximate it, it will be square root of 10 power 4, 8, which can give you the value of 10 power 4.
Sir, I have a doubt.
Yeah, please.
Sir,
Tell me.
isn't XC 1 by omega C?
Hmm. Oh, I wrote it as omega c itself.
Yes, sir.
Hmm. Is answer changing accordingly?
Yes, sir. We get XC as 2 into 10 power 4, sir.
Sir, V effective is 2.25 into 10 power 10.
1 minute.
Sir, V
2.25.
effective is correct.
V effective, 30 volt is right.
Yes, sir.
But how come we got same answer? Is it? So 1 divided by omega is going to be 100 into C is going to be half into 10 power minus 6. So even then this 2 will go to the numerator only, no?
Sir, it's not about here, sir.
Yeah.
30 volt is
I
correct.
was wondering, I understand, but the mistake is, fortunately we got that answer. Yeah, that's right. So it is 1 by omega c, guys. So 10 power minus 4, so 3 into 10 power 1, which is going to be 30 volt. So the answer we got is actually luck. So it is 30 volt. Upper impedance will be how much? Upper impedance will be 2 into 10 power 4. Sorry, correct?
Yes, sir. Yes, sir.
Reactance will be 2 into 10 power 4.
Yes, sir.
So 2 into 10 power 4, then you can't ignore the value. So it is going to be 4 into 10 power 4.
Sir,
4 into 10
2.3
power 8.
into
4
10
into
power
10 power 8. 4 into 10 power 8. So what will you get here? You will have 4 into 10 power 8. Right. So you'll have square root of 5 into 10 power 8. So 10 power 4 into square root of 5, which is 2.25 approximately. Is that right? So 5 into 10 power 4, 2.25 into 10 power 4 ohm is going to be the effective impedance. Correct?
Sir, could you go back to the previous page?
Mhm.
Just a minute, sir.
Mhm. Done means let me know that. I'm waiting for it.
Yes.
Yes means done, no?
Yes, sir.
So again, this problem is not needed. See, these are all very rare that you will get. So the next set of problems that we are supposed to do is series RLC circuit, its resonance, and something called as Q factor. Right. So when you talk about a series RLC circuit, what is going to be the impedance? Impedance is ERMS divided by IRMS, which will be equal to square root of XL minus XC the whole square, or it will be R square. Somebody's mic is on. Can you please switch it off? So it will be
Sir,
root of R.
Can it be also XC minus XL?
It can be depending on the values. Okay, generally we take XL minus because it's a square only, no? Depending on which one is more.
Yes, sir, that's all.
Yeah. So phase angle phi is going to be tan phi only again. So tan phi will be equal to XL minus XC divided by R. This is where I want you to understand. So for RL circuit, what is going to be the value of tan phi? It was XL divided by R. For RC circuit, what was tan phi? It was XC divided by R. Whereas for LCR, what is the value of tan phi? It is XL minus XC divided by R. But if you see in all the three cases, this cos phi is written as R by Z only. Any idea what is the name of this cos phi called as? It is called as the
Power factor.
It's called as the power factor. Where do we get this power factor? In the case of derivation of power, right? So cos phi is always R by Z, where R is the resistance and Z is the impedance. Third, resonant frequency of LCR series circuit when is so when you say the series RLC circuit is in resonance, when XL is equal to XC. So when you calculate the frequency, it will come out as 1 by 2 pi into square root of L into C. And the last one is Q factor, which is also called as the quality factor. So quality factor is defined as the ratio of the resonant frequency to the difference in those two frequencies where the current is 1 by root 2 times the peak value. 1 by root 2 times, instead of saying peak value, I would say 1 by root 2 times the resonant value. Okay. So it is also given as omega R into L by R or 1 by R into root LC. I want everybody to make a note of the points in the slide. Most of the questions are given from these expressions only.
Sir,
Tell me that.
sir, how are we writing omega naught L by R as 1 by R root L by C?
There is a derivation which is not a part of your syllabus, so that's why I didn't explain it. You can just have these values in mind.
Okay, sir.
Okay. See, first of all, you should know like there is a derivation for getting this omega R into L by R, but we know that omega R is equal to 1 by root LC. That you know. See, FR
Yes,
is
sir.
1 by 2 by root LC, omega R is 1 by root LC. So substitute that value there. 1 by root LC into L divided by R. So what will you have? 1 by R into root of L divided by C. 1 will cancel this. So that is why you got 1 by R into root L by C. This is the
Yes.
most common used expression. Okay, actually, if you see your textbook itself, there'll be a big derivation for this. You will get a quadratic equation and then you will find the sum of the roots and all those things and then write that omega R into L divided by R. Okay, so shall I proceed? So find the value of this. Determine the impedance of series RLC circuit if the reactance C and the L are 250 ohm and 220 ohm respectively, and R is given as 40 ohm. So Z is equal to root of R square plus XL minus XC the whole square. So square root of 40 square plus XL minus XC the whole square is going to be 30 square. So square root of 40 square plus 30 square will be 50. Because 3, 4, 5 are Pythagorean triplets. Similarly, 30, 40, 50 are also Pythagorean triplets. Next, do this. You can definitely expect a problem from series RLC circuit in this chapter. A resistor of 50 ohm, an inductor of 20 by pi Henry and a capacitor of 5 by pi microfarad are connected in series to a voltage source 230 volt and 50 hertz. Find the impedance of the circuit. I'm having some network issues. What is the answer for this?
50, sir.
Correct. So how to do this? Resistor is 50 ohm. Inductor is inductance is 20 by pi. Capacitance is 5 by pi into 10 power minus 6 are connected in series, and a voltage of 230 volt and 50 hertz is connected. So Z will be equal to root of R square plus XL minus XC the whole square. So what is going to be the value of XL? Omega into L. Omega is 100 pi into L is 20 by pi. Cancel these two, you will get 2 into 10 power 3. XC is 1 by omega C. So 1 by omega is 100 pi into C is 5 by pi into 10 power minus 6. Pi and pi will get cancelled. So 0.2 into 10 power
10
4
power.
or 2 into 10 power 3. Correct?
Yes, sir.
So XL is equal to XC na enna condition ida?
Resonant condition.
In resonance condition, a series LCR circuit will behave like a purely resistive circuit. Okay, there is an important point I want everybody to make a note. This is also another type of question that they can ask you. Okay, so in a series LCR circuit, if XL is equal to XC, we know that it is resonance condition. But second point to be noted here is circuit behaves as a purely resistive device. Next, inductor is 0.3 Henry. Capacitance is 60 into 10 power minus 6 farad. Resistance is 50 ohm. Connected in series with a 120 volt. So V effective is equal to 120 and F is equal to 60 hertz. Calculate the impedance of the circuit. So what is the impedance? Z will be equal to root of R square plus XL minus XC the whole square. So what is the value of XL? Omega into L. XC will be 1 by omega into C. So it is going to be 2 pi F into L, and XC will be equal to 1 by 2 pi F into C. So 2 pi F is how much? 120 pi into L is going to be 0.3. XC will be 1 by 2 pi F. So that is going to be 120 pi into C is going to be how much? 60 into 10 power minus 6.
Sir, can you show the previous slide, sir?
This one, huh?
Or not? No, sir. The previous one.
This
One
one?
second, sir. Thank you, sir.
Yeah. See, this slightly a tougher calculation only, but you cannot expect these kind of problems, but if you know the concept is sufficient, okay. They'll not ask you this stuff where you'll have so much of calculations to do. Okay, the values are given here. The logic is same again. Everywhere we have been doing the same thing, right?
Sir, is impedance 85.2.
The இருக்குடா 85 ohm. Okay. So you can just take a screenshot of the slide. So always it is suggested that you calculate XC separately, XL separately, and then proceed with the problem. Okay. So last set of problems. Okay, one more thing is transform is also there. I think transformer, let me check if it is there. It's there. So two more concepts that are left out are, one is energy and power associated with AC circuits, and the next set is transformers based problem. So we'll see few problems based on these concepts and then wind up. Okay. So what is going to be the average power consumed per cycle in an AC circuit? It is given as ERMS into IRMS into cos phi, or it is also sometimes written as E naught by root 2 into I naught by root 2 into cos phi. Okay. So this ERMS into IRMS is also given a name called as apparent power. Okay. Next, what is power factor? Cos phi is given as R divided by Z, and here Z is going to be root of R square plus XL minus XC the whole square. Next, so when you talk about a purely resistive circuit, what is going to be the average power consumed by it per cycle? It is going to be E naught square divided by 2R, or it is going to be equal to ERMS into IRMS, or it will be ERMS square divided by 2R. Okay. Next is the energy stored in inductor is given as half Li square. And the most important point to be noted here is the average power consumed per cycle in a pure inductive and a capacitive circuit is 0. What is the name of this kind of a current? It's called as
Wattless current.
current. So wattless current is basically that current which does not consume any power. So energy stored in a capacitor, you already know, half CV square or Q square divided by 2C, right? And you know this also for a series LCR circuit, XL is equal to XC or FR is equal to 1 by 2 pi into root LC. Okay. So having said
Sir.
this, tell me.
Sir, then apparent and average power is same, sir. ERMS,
Same.
IRMS.
ERMS into IRMS is average power only for purely resistive, no?
Yes, sir, and average power also ERMS
Average
into IRMS.
power cos phi irukeda. Cos phi irukku. So ERMS into IRMS multiplied with cos phi is the average power. Only ERMS into IRMS is going to give you the apparent power.
Okay, sir.
Okay.
Sir,
Sir,
in the slide, both places it's given P average.
where?
Sir, P apparent only should be ERMS into IRMS.
You are not reading this part, Ra. See, average power consumed in any AC circuit is ERMS into IRMS into cos phi. Any AC circuit means it can be a resistive, it can be a capacitive, it can be an inductive, or it can be RL, RC, or RLC. That is the meaning of any AC circuit. But if I take only the first two terms of the multiplication factor, ERMS into IRMS, that is given a name called as apparent power. If I take the average power consumed by cycle in a purely resistive circuit, so in a purely resistive circuit, what is the phase difference existing between the current and the voltage?
0.
So when
Zero.
I take the 0 and substitute it here in this cos phi, what will I get?
Yes, sir. Understood.
1, 1.
That is why it is written as ERMS into IRMS. Whereas,
Understood.
yeah, inductive and capacitive, for others' sake, I'm explaining. For inductive and capacitive, the value of phi is going to be 90. If you take this and substitute it here, average power is 0. That is the meaning. Okay. So having this in mind, let's solve the first problem. So there is a light bulb which is rated at 100 watt for a 220 volt supply. Find the resistance of the bulb, the peak value of the source, sorry, the peak voltage of the source, and the RMS current through the bulb. So light bulb is rated at 100 watts. So power is equal to 100. So VRMS is equal to 220 volt. Find the resistance of the bulb. Resistance will be equal to VRMS square divided by P. Am I right? So it is going to be 220 square divided by what is going to be the value of P? 100. So 48400 divided by 100, cancel them. Answer will be 484 ohm. Calculate the peak value of the source. So VRMS is this one. So V naught will be equal to 220 into root 2, which is going to be 311 volt. What about the RMS current through the bulb? IRMS is equal to VRMS divided by R. VRMS is 220 divided by 484. Or I can write, the easier way is, since it is a purely resistive circuit, P average, can I write it as ERMS into IRMS? So P average is 100, ERMS is 220 into IRMS, which implies 100 divided by 220 is going to be IRMS. This and this will get cancelled by 11. So 5 by 11 will be the answer. Do this fast. A capacitor, resistor are connected in series with an AC source. If the potential differences across the C are 120 volt and 90 volt respectively, and the RMS value of current is 3 ampere, calculate the impedance and the power factor of the circuit. So V effective will be how much? Root of VR square plus VC square. So it is going to be root of 90 square plus 120 square. Is going to be square root of 22500. So how much will this be? It will be 150. So 150 volt is the effective voltage. So we need the impedance. So impedance is equal to how much? V effective divided by I effective. So 150 divided by 3, which is going to be 50 ohm. So that is the value of Z. What about the power factor? So power factor is equal to cos phi is equal to R divided by Z. R is how much?
30.
R is 30 divided by what is going to be the value of Z? It is 50. So it will be 3 by 5. So cos phi is equal to 3 by 5, and this is going to be the power factor. 0.6. So how to get that 30? 90 divided by 3. I hope you could understand. So these kind of problems you can expect. Okay. So one more problem based on
Sir?
power. Tell me, Tom.
Can you show the previous one? Yes, sir.
Okay. So alternating voltage is given as V is equal to 200 sine 300t is applied across a series combination of R is equal to 10 ohm and an inductor of 800 millihenry. Calculate the impedance. So Z is equal to root of R square plus XL square. So for me to calculate XL, I need to write omega into L. Omega is how much? 300 into L is 800 into 10 power minus 3. 1, 2, 3 zeros are cancelled. So 240 ohm. So Z will be equal to root of R square. That is going to be 100 plus 240 square, which is 24 is 576. 57600. So how much would be the answer? Root of 57700 under root. So it'd be 240 point something only, because 576 is approximately 240. So 577 will, sorry, 576 is 240. 577 will be
240.2. Sir.
240.2 or the 240.2 ohm. What about the power factor of the circuit? Cos phi is equal to R by Z. So 10 divided by 240.2. Okay. So I hope you could get some grip on these kind of problems also.
Sir,
Tell me, Ram.
sir, in that question, sir, we need to find peak value of current, right?
Oh, they asked the peak value. So, you know, this is the peak value, 200 stands.
Sir, it is V naught, sir.
Yeah, 200 by 10, 200 by 6.
Yes, sir.
Again, see, everything is similar. By now, you would have got a grip on it, right? Everything is a similar kind of a problem. So this we can discuss LC oscillations. Maybe we can discuss it in the EM waves part. So the last concept that we are going to see is voltages and currents in a transformer. That is transformer mainly. So mostly they will not ask you problems, but for safe side, it's better. We know we have a grip over it. We'll do 1 or 2 problems based on this. So voltages and current in a transformer are related as E2 by E1 is equal to I1 by I2, because we assume that there is no power loss. Right. And E2 by E1 is also given by as N2 by N1, and which is also equal to a number called as K, where K is called as the transformation or turns ratio. So generally 2 is used for secondary coil and 1 is used for the primary coil. Okay. So this is one thing. Second is, if they ask you what the power in the primary coil, it is E1 into I1. Then the power in the secondary coil is also E1 into I1 because we assume that there is no loss of power. And what is going to be the efficiency of the transformer? It is going to be output power divided by input power multiplied with 100. Okay. Next. So do one problem, that is enough. The primary coil of an ideal step-up transformer.
Show the previous slide.
Sure. Make a note of it.
It will be E1 I1 is equal to E2 I2, right?
E2 I2, that's what? E1 I1 is equal to E2 I2. Mathematically, they are the same, no? That is why it is given like that.
Sir, what is turns ratio?
Thank you, sir.
Okay. I1 by I2 or N2 by N1 or so N2 by N1 is called as the transformation or the turns ratio. Turns, the number of turns.
Yes.
See, it's very rare that they use these terms in the exam, but it's better you know them. Okay. If it comes, let's not lose marks. So the primary coil of an ideal step-up transformer has 100 turns, and the transformation ratio is 100. The input voltage and the power are 220 volt and 1100 watt respectively. So N1 is 100. N2 divided by N1 is equal to 100. And input voltage E1 is equal to 220 volt. And input power E1 into I1 is 1100 watt. Calculate the number of turns in the secondary coil. Can you calculate it from here? N2 will be equal to 10.4. Done. Calculate the current in the primary coil. So E1 is given, substitute it here, 220 into I1 is equal to 1100, 5 times. So I1 will be equal to 5 ampere. Done. Voltage across the secondary. Voltage across the secondary is what is the voltage across secondary?
Same power.
So E2 by E1 is equal to N2 by N1. N2 by N1 is 100. E2 is equal to 100 into E1, 220. So 220 into 10 square volt. It is 22,000 volt because it's a step-up transformer. It's right. 220 volt is given, 22,000 is taken out. The current in the secondary, can you calculate? So E2 into I2 is equal to 1100. So E2 is 22,000 into I2 is equal to 1100. 2 zeros are gone. So this will cancel this 20 times. So I2 will be equal to 1 by 20 or 0.1 divided by 2 or 0.05 ampere.
Sir,
Tell me them.
sir, why did you do for the second one 220 I1 equal to 1001?
Where? You can do from anything.
Sir, when you
the
no, could
current
you
is
explain it? I did not understand it for the second one.
220 into I1. See, E1 is given, power is given. So we know that E1 into I1 is equal to power across the primary. We wanted
Understood,
I1,
sir. Yes, sir. Yes, sir.
yeah. So power in the secondary is obviously we need not calculate 1100 only. Right. I hope you could understand. It's actually a simple concept. Only thing is you should
Yes,
remember
sir.
that. Yes, it's a simple concept. So let's check the values. So first one is 10 power 4. Second one is 5. Third one is 22,000 correct. Then 0.05 correct. That's it. So 1100. So I hope you understand. No? There's a maximum level of problem you can expect in transformer. That too, I'm guessing this might come in the case study based questions. Because it's a theoretical concept. Okay. If at all it comes, don't miss it. So this is all about alternating current. Every other problem, these are the 5 different formulae. You guys can try it once the sheet comes. Okay. So I hope it is clear, no? Any other doubt or any other concept that is bothering you? Can I have some response? Everything is fine?
Sir, I have a doubt, sir.
Tell me that.
Sir, in transformation ratio, it is generally N2 by N1, or can we also take N1 by N2? Sir?
It's N2 by N1 is taken as transformation ratio. If you take N1 by N2, it should be 1 by K.
Sir, is
Then
it same for both step up and step down, sir?
Yes, it's same. It has nothing to do with whether it's step up or step down.
Okay, sir.
But generally, see why we write the E2 in the numerator is generally you calculate efficiency or anything. We have the habit of writing output in the numerator. E2 is the output. So output by input that is given a name called as transformation ratio. If you want to write it as N1 by N2, you should not call it as transformation ratio. It will be the reverse of reciprocal of it. Be careful with it, okay? If you change that, none of the answers will match here. Kaushik, one doubt na clear பண்றேன். See, for example, N1 by N2 நான் K எடுத்திருந்தா, okay, then I should have written N1 by N2 is equal to 100 according to this question, correct? அப்ப N1 what would have happened? அப்ப N2 என்ன இருக்கும்? N2 will be N1 by 100. N1 எவ்வளோ? 100 divided by 100. What would have happened? So what is the meaning of this? N2 is equal to 1 and now what is the meaning of this? It is actually acting like a step down transform. The question that they have clearly mentioned, it's a step up transform. So I cannot swap the values. I need to take it as N2 by N1 only. சரியா? Careful.
Yes.
That you will help others also. Sorry, where other doubt? Any other doubt?
Sir, LC oscillation is not there, right?
I think so. It is deleted. Once let me check. I have the sheet open. Resonance. Yeah, LC oscillation is not there. I'll tell you what are all there. Alternating current introduction, peak and RMS value we solved. Then we have reactance and impedance concept. Then we have LCR series circuits, resonance power in AC, power factor, wattless current, and transformer. We solved everything. LC oscillation illa. Edra? Phasor diagram.
Okay, sir.
For LCR circuit, they told phasor diagrams are there. But it's better, I would suggest the CBSE people, please don't trust, okay? On the syllabus, sometimes in paper, they will ask something else. It's better you be prepared with it.
Okay.
LC oscillation is fine, but we have already discussed, this is way more than what is required for CBSE. But either way, correct up, you can easily score good in this chapter.
Okay.
So, yeah. Okay. Sorry. Well, if no more doubts, we'll wind up.
Thank you, sir.
Okay. Yeah. Thank you. Bye.
Thank you, sir.
sir.